sweet and sticky. Yeah.
As long as my fact point works.
Okay. All right. Okay.
Wow. Okay. I think this is open. Wonderful. Hi, everybody. You're in Plaza A. This is San Francisco, and you are attending the IoT Ops working group of the IETF117. I recommend everybody takes a seat or ceases private discussions for the moment because we are starting the session. Hi. So I'm Henk, and my dear co-chair is Alexi.
Hi.
And we have some well-known rules. They are known as the Notewell. I assume that most of you already encountered them. If not, they are available on the meeting material, and a lot of interesting rules here. Some of them are code of conduct, which basically means be nice to each other, so treat others as you would like to be treated. That sometimes is not very obvious. We have technical problems here, and if there are individual problems with people, please try to resolve them, or there's an ombuds team. When you look at the data tracker, you will find several icons over there. There's one that is a camera, that's the full meeting, and there's another one that's the light thing meeting. When you are in the room, you can raise your hand. I placed the blue sheet at the front mic, so when you can't scan this QR code over there because it's too far away or something, and you want to go to a mic, the front mic has the blue sheet that is just that QR code now. And then you register for being an attendee at this working group meeting, and that helps the IETF to make better room and scheduling decisions. That would be really nice. This meeting is recorded, by the way. I just skipped that slide. So that's the basic guides. Effectively, if you find any issues with what I've just said, there's an interesting link here at the bottom where you can report issues. That actually really helps. The data tracker does not always work as intended. So if you find something that you find irritating or could be an improvement, please go there. And now comes the time when we ask for note takers. There's a link here. That's the notes. I will. Could you paste the notes link in the chat, maybe? And we need at least one individual in the room that has the capability and the attention span to create some. Sorry, notes. Yeah, and we this is a hard blocker for the meeting. We have to select a minute taker that does notes. Are there volunteers for this role? I mean, the basic prerequisite is like remembering or understanding the name of the person presenting or asking a question, then writing down decisions. If there's something controversial, that also is interesting. So I'm only continue talking because we need a note taker, please. Someone in the room? Again, this is hard blocker of a process, so I would be really happy if there would be a volunteer coming up and telling us, yes, I can do notes. That is not a big issue. And you wouldn't believe how persistent I'm with this. So in case there's, so maybe I'm not using the right words, we can't continue without a note taker. And so there's the need for that. And you, you're really sacrificing yourself. Wow, okay. Our AD takes up your work. Maybe. Thank you, Warren. So in any case, if you find something in the notes, you can follow the notes. It's an interactive CodeMD, Hedgehog, sorry. And so you can add to the notes. So there's no limit for people joining the minutes and adding something to that. Okay, having done that, crossed that threshold, we have agenda for today, which is basically I'm talking here to you, maybe a little bit longer than I thought, for 5 minutes. Then we will have Brandon as our first presenter. As you can see, that we have a relatively lofty agenda. We will talk about 2 adopted items, and then about the device schema extensions to the SCIM model, which I think nice for you to bring here. And final item will be a Brewski subset and topic presented. And then any other business, which basically means open mic. So is there any agenda bashing that the room or the remote attendees want to have? And I'm looking at the chat right now. That does not seem to be the case. So I will niftily switch to is this the right one?
No, you didn't do the right thing.
I didn't do the right thing.
Oh.
No.
No. Yeah, do this.
And do it.
No.
See, I can learn things. And there we go.
Can you hear me okay?
Yes, Brendan, you are online and we can hear you in the room.
All right, great. Next slide, please. So I'm going to talk a little bit about why we're doing this IoT security survey draft. Suppose that you're working for a company that makes some kind of IoT device, medical devices, maybe, that didn't used to be IoT, but now they have to be. SCADA systems, which probably shouldn't be IoT, but are. Industrial robots, same deal. You know, there's many, many more of these kinds of things, and they need to be connected to the internet. Well, suppose then that your latest client tells you that they need their devices, anything that they buy, anything that they commission you to build for them, they need to adhere to one of the security recommendations documents that has been produced by various other standards organizations. So, you know, like the ENISA baseline security requirements, or sorry, recommendations for IoT systems for critical infrastructure, or NIST 8259A. And there's many more. Well, now what? Next slide, please. Well, the requirement documents don't actually tell you how to implement them. They don't tell you where to look for standards that would help you. They don't tell you where to find libraries that would help you. They don't tell you anything other than what you need to do. They don't tell you anything about where to find help, where to find the right kind of tools to do your job. So that's going to be a problem. The IETF also doesn't today have a landing pad document which tells you, you know, if you're trying to build a secure IoT device, these are the kinds of things you need to look at. And these are the kinds of protocols we have that can help you. We don't have that today. The discovery process for this is actually really complicated. If you want to know what you need in order to get your IoT device built and deployed, you're probably going to end up just picking an IoT operating system and hoping for the best. So going, yeah, it should probably handle all of these. But that's inevitably going to result in audits, security audits telling you that you're missing something, and it goes on, and you'll end up blowing your budget and going past your deadline. So what can we do? Next slide, please. Well, that's where this comes in. So the IoT security survey document maps security requirements from existing standards or recommendation documents to IETF and related technologies. I say IETF and related because there are certain technologies that we don't and can't cover in the IETF because they operate outside our purview, but are critical to how we anchor our security. And as such, they do need a little pointer in this document. So this provides implementers with a starting place for their IoT security, and it serves 3 distinct purposes. The first is it directs implementers towards standards-based solutions to security requirements. And if we don't do that, then implementers are going to roll this stuff on their own because they know they need it. And so if they don't know where to find a standard or can't find a standard that does what they need, they'll just do it themselves, and we'll end up with an interoperability mess. The second purpose is it helps make implementers aware of the security problems that they might encounter when deploying IoT devices that they may not have considered. Not every implementer is going to think about how to secure the private data that their device collects and processes. They may not consider whether they need trusted execution environments, et cetera, et cetera. So that helps them to discover these possibilities and these security problems that they may not be considering. And then third, it ends up mapping security requirements between different requirement documents. I promise I did not mean to do that. That was an accident, but the structure of the document exposes it. So there you go. Next slide, please. All right, so the current status is that we've got two sets of security requirements that we've already covered. I say we, I need another author, please. So first we've covered the ENISA baseline security recommendations for IoT, and second, the NIST IoT cybersecurity capability core baseline. So those are the only two that are in there. The working group in the last meeting at IETF 117 specifically asked not to split this document into one mapping document per standard. Now, what that means is that this is going to grow a lot until we decide that there are enough standards in it. And because of that, I need co-authors because I don't want to be mapping every single security requirements document out there to IETF technologies. We also need reviewers. And I suspect the next step here is to add ETSI's cybersecurity for consumer Internet of Things baseline requirements draft. So that's where we are today. Next slide, please. Now there are some questions probably covered, like, why isn't my favorite set of requirements covered? Well, the answer to that is clear. It's because you're not a co-author yet. Join me. Then the other question I have is, what does this draft need for working group last call? And that's it. That is what I have. And I guess the question here is, who wants to join me? And what have I got wrong?
Yeah,
Go on. Just yeah.
Robert?
Bob Moskowitz. I'm doing a much simpler document on my own, dealing with how to make X509 certificates and a little test PKI. And I'm doing it all on my own and learn how hard it is to work with OpenSSL. The reason I'm getting up here is that a document like this, as neat as this, should never, ever, ever become an RFC. This is using the Internet Draft Repository for a living, findable document on recommendations. It is, in my highly biased opinion, the best way for doing such a thing. GitHub is the wrong place to think about doing this, or a wiki. Putting it in an internet draft, as you have done, and I applaud you on this, that is the place for keeping these living recommendations. And at some point, you're going to hopefully, Brendan, hand it over to somebody else who's going to continue to run with it. And hopefully this is something that 5+ years from now, they'll still be there. Because 5+ years from now, the people who develop these protocols are busy doing something else. And the new group of people trying to implement something say, what am I supposed to do? So this is, I will take a look at it, see if there's anything that I may be able to add to it. But it is, I vote in favor of this being obviously the workgroup document and always being a draft.
Fair enough. I think in one of the previous meetings, I mentioned that I could see this being some kind of a living document. I'm not sure exactly what the protocol is for that in the IETF. A perpetual draft, I understand why that's appealing, but at the same time, it doesn't really give the air of authority that you might want in something like this.
Yeah, that's a bit of a problem. But Roman long ago said that version numbers are free. So you want to update it, you go ahead and update it and put a new version number.
Oh, thank you. I was about to ask our responsible AD to comment if he has an opinion.
I've got an opinion. I don't know if it's a good one. Warren Kamari. So we do keep talking about the concept of sort of living documents, which would basically be sort of like an RFC, but much easier to update. Right? The problem with an RFC is you publish it and then it's such a fact to ever update it that you would never touch it ever again. So this might be something that fits well in the living documents type thing where you publish sort of point revisions every now and then, like kind of like semantic version type ideas. But that's a discussion that's been going on for many years and hasn't got anywhere. But now I think let's work on it as a draft, and we'll cross that bridge when we get to it, if we get to it. But thanks for doing the work. And who's going to be a co-author? Someone volunteer.
I said I'll look at it. Let's go off and not see.
We might have to rank the people.
So as a chair, I can say that this IETF meeting met quite a few people coming from other. Oh, sorry, and Elliot, I just saw you entering the line. I'm skipping you. Sorry, yeah. And this is a new search of representatives from other SDOs can be leveraged. And as a chair, I can float this, and I think it's a responsibility of others to maybe do the same. But I actually would be able maybe to find one or two other co-authors when we start to float this, because as a landing point, as you say, you need experts from others, baseline security document owners, or at least interest groups and that use them, and I think it's a shared responsibility to help you there, and that's something I think the chairs can help you with. And now Elliot, sorry for basically skipping the line.
Yeah. Hi, everybody. I don't know about co-author, but I'm happy to try and be a contributor to the document in terms of, maybe helping a little bit here, a little bit there. I'm not sure if I'm quite qualified to be a co-author, but I find Brendan's writings to be interesting, fun, and accurate. So to be able to participate there would be an honor.
That'd be great. Thank you, Elliot.
Okay. Thank you, Brandon.
And John, take it away.
Yeah, so there, press the wrong button. Guess you can hear me. So this is about the comparison of co-op security protocol documents, which is now in version 02. The photo I took here has nothing to do with draft at all. Next slide. The version we discussed at the last IETF was 00. We have quite a lot of discussion in IETOPS before the last IETF, during IETF, and after IETF. And this was then included in 01 and 02, which I think addressed all the issues and comments raised at that point. Added some references to the list and GitHub. Then was quite a lot of discussion about the underlying documents. The 02 version makes it clearer that the focus is on the security protocols and not on underlying layers. Then there's no section discussing some things about underlying layers. My recognition of what the group kind of agreement was that we don't want to spend too much time on the underlying layer, but we need some discussion so people understand that underlying layers can affect this and how to look for more information. Changed conclusion to summary, corrected the group OSCO number as pointed out by Marco, then a new section on EDOC over COAP and OSCOR. This is a subsection to the underlying layers, and all this, the material there was provided by Marco. Thanks, Marco. Updated with CTLS 08 and updated tables to make it clear that it is the 08 version. My feeling is that CTLS is now a bit more stable with respect to this draft. Haven't heard any final decision from the CTLS people, but it seems like they will not do any optimization for P256 and instead focus on X25519 and EDDSA. And that means that there's no changes to the current draft, and any future changes would affect the numbers much less, like a few bytes instead of 60-70 bytes. And then there are some editorial changes. Next slide. Then we have gotten an early IOTD review by Russ. Thanks for that, Russ. And Russ has raised some issues and also have very good suggestion for how to fix them. Two major issues. The first is about terminology. The different protocols use different terminology. And the other is about that the protocols are quite different, the key exchange and like the TLS handshake and the TLS record layer. And as Russ discussed, this should be a discussion of the comparison methodology. Makes a lot of sense. Should probably also be more terminology section. Then the other major thing is about the security consideration, which is currently empty. Russ suggests to at least refer to the security considerations in the security protocols. This also makes a lot of sense. The next two sections are about the underlying layers. And yeah, he discusses whether this is needed or not, and if it's needed, he suggests that should say which protocols are used with which underlying layers. That makes sense. And then he points out that 2.1 is quite detailed and asks why that is more detailed than the rest. I think that can be discussed, but I think the reason I see is that the discussion here is still on these underlying layers affect the COAP layer itself. Other things are purely in the underlying layers. So this still discusses COAP and the security protocols. Then section 3 references to algorithms. This is the key exchange. I think maybe that's relevant for section 4 also. Makes a lot of sense. And then there is a NIT about 3.1 about key certificate identifiers. I haven't looked into how to solve this, but I think all of this makes a lot of sense, high level. I think my plan is to fix that, address these in 03 quite soon. Next slide. So next steps, address the comments from Russ, submit 3, and with that, all the issues and comments have been addressed. I think we authors don't have any concrete plans, things we want or think should be done. Before we move to IETF, our last comments in LVIG was that we thought we were ready for working group last call. I think this document needs more reviews, people that read the whole document and comment, whether that's before a working group last call or during a working group last call is up for the group and the chairs to decide. But I think we need more reviews and see if there is something more missing. That's it.
John, question for you. So in regards to CTLS, do we need to wait until CTLS is published, or is this going to be just a snapshot in time, or like just trying to figure out whether we do like last call and park the document, or what do you think we should?
That's a good question. I don't have an answer to. I think both options are viable. Either we push it now. I think CTLS has, if any changes, I think it's small changes, a few bytes. So I think we could publish it or like now, or we could wait for CTLS, and we decide that it's not published until that's published. But I don't know how long. CTLS is probably the longest waiting time of the drafts that are referenced.
So chairs probably should check with, is it TLS working group? Is it TLS working group for CTLS? Yeah, all right. So we'll probably need to check with chairs and just get an indication of, and then we can come back and discuss in the working group what we, okay.
Right.
Thank you.
Yeah, this is Henk as the chair. You said we will address the issues of Russ. If there's anything you need, of course, the list is there for you to help. So if you encounter any blockers on that next to the CTLS, which we will take on, just say so.
Hey, everybody. Okay, this draft is not meant as a working group draft for IoT Ops, but rather is about to be adopted by the SCIM working group. The reason I'm here is because the IoT Ops group asked me to come back here and talk about the any updates to this draft. And so, next slide, please. This is sort of a cool deck. I actually use the same deck in SCIM, but I'm going to take more time here because they actually, they're up to speed on what's going on with it. So what's the goal? The goal is to abstract out the different onboarding mechanisms and offer provisioning interface to, well, all of them. And so one, basically SCIM, if you recall, is a user provisioning mechanism. We're going to add functionality to do device provisioning. We're going to reuse the core schema. We'll reuse the group schema as well, which is also part of the course, also part of the core. And so there's a lot of reuse going on. Next slide, please. So one big change is typically enterprises use SCIM to call out to their providers. Like for instance, the enterprise might use SCIM to call out to their payroll processor to say, hey, I've got a new user, or hey, I've deleted a new user. Or they might do that with WebEx or with Microsoft or whoever to provision accounts. Very classically used in Salesforce.com. They were a major driver of this technology. In this case, communication actually reverses, And partners who are providing IoT devices into an enterprise environment will call into SCIM, will call into enterprise, who will act as the SCIM service provider and say, okay, here's a new device that's coming at you, and here are some of its parameters. Other components of this mechanism will include an ALG. We're going to talk about that more in Prague, and this will link to that. So the idea again is to cover multiple technologies, including BLE and Zigbee, as well as Wi-Fi and wired. Maybe some thread in there, maybe other things depending on what other people want to do. We've had some interest in FDO, so maybe we'll do some stuff with FIDO device onboarding as well. The idea is just to be able to say, okay, here's your gateway, just point to a particular set of functions for control for the device, and then use that within your infrastructure. Next slide, please. So the schemas that are in use, you've got the core device schema. The core device schema has very little information, like display name, an admin state, and an optional MUD URL. And the MUD URL could pass additional information about a particular device. And then you extend and extend and extend. And we include a bunch of extensions to start off with. So the initial extensions include BLE, Wi-Fi Alliance Easy Connect, Zigbee as the type of devices. As I mentioned, there is a little bit of interest in FDO. We might do something there. And there's a little bit of interest in Thread / Matter. We might do something there if we can figure out how to do that. Now, for non-IP devices, this basically provisioning a device also may entail provisioning an application layer gateway. And so for that, we've also added an endpoint application authorization mechanism so that we know which applications are allowed to actually communicate to that application layer gateway. Next slide, please. Okay, so we've done a few updates since we last spoke. We've really done a lot of work on the endpoint application schema. We need to do a lot more work on the endpoint application schema. But mostly this involved changes where, the initial draft had like a raw public key or something like that in it to identify the endpoint applications. Well, that's sort of bad. And so we've cleaned up some of that. We have also addressed a couple of other issues in the draft that involved the BLE schema between whether devices bond or they don't bond. We'll have some more work to do there, I'm sure. We've noticed a couple of issues, one of which is the primary author on this is a non-native speaker, and there's some language that needs to be a little clearer. He did a really good job considering that. I mean, it's actually did an amazing job. But we've asked, a couple of people said, can you be a little clearer in the introduction? We've blown the regex for the MAC addresses in a couple of places. It's inconsistent. In one case, we're allowing a MAC address to have an extra character, which seems a little bit, wrong. So we're going to fix that. The draft actually has normative narrative text as required by the SCIM core documents. We've also included an open API model in there as well in the appendix, so people can just suck in the open API model and just test to their heart's content. And I'll come back to that testing and playing part in a little bit. There are some formatting issues with JSON, with JSON examples. Anytime you have JSON examples in a draft or an RFC, you just want to beat your head against the wall. I know I've done it. So, I mean, how many people in the room have had to implement a folding function for JSON in their work? Hands up. Okay, just me. Oh, Warren, see, I saw you there, Warren. Okay. So we've had, and I didn't quite get it right. Maybe I'll use your code, Warren, if you want it. And then we actually want to hack the code. So we're intending to release some OSS. I was hoping to have it by now, but it's probably just a couple of weeks away. We were in a doc review, and then I had the bad sense to go on vacation. So that's completing, and we're going to get some code out there for people to play with. And then we want to hack it all around in Prague. We're trying to arrange for that. So as I mentioned, the working group adoption call just closed in Skim. We're expecting at least one more comment. And that's really it. And I see, Hannes, you have a question or a comment?
Hi, Elliot. I have a question about the architecture slide you showed. I'm not quite sure I understand how you want to use sort of the schema, the protocol. So could you maybe sort of explain it based, let's say, on FDO, because I'm more familiar with that. How would that work?
So, yeah, you picked the one that we haven't done yet. So I'll give it a whirl. How about that? So imagine that green box on the bottom saying FDO. And so in FDO terms, you have an owner process, which allows for ownership transfer. And it would have access to the FDO voucher for the device. And so the idea would be that the provisioning function at that point for FDO would be to simply provide the voucher. The gateway function there is that you see, you can imagine all those green boxes being all one if you want, but the gateway would say, oh, this is FDO, let me send this off to the FDO owner with a particular voucher, so that when the device bootstraps, the owner process will already have the voucher. Does that help?
What?
And I'm sort of doing that on the fly, okay? Because we haven't actually done that code. Maybe you want to hack that with us in Prague.
Because in FDO, for example, you would have the rendezvous server. So obviously you may not want to connect to the rendezvous server. So, and the other one is sort of the service where you literally sort of like kind of the device management service where you connect to, and you would connect to that. You would push the voucher to that sort of device management service.
Yeah,
but you wouldn't,
that's sort of
do anything. It's basically, it's a provisioning mechanism for the backend infrastructure.
Exactly.
Okay.
You have it in one. In fact, a design consideration for us was specifically that we didn't want to screw around with the left side of this picture. Like we don't want to change the devices themselves. This just builds on what everybody else did. We already have enough onboarding mechanisms. We don't need more. I don't know, maybe we need more, but we can accommodate that if we need to. The idea was that I didn't want to write another onboarding mechanism. I just wanted to maybe be able to provision the ones that were there.
Okay, I think I understand now. Cool, thanks.
Okay. Sorry I couldn't be there in person to present, by the way. I hope you guys are having a great time in San Francisco. Any other questions, comments? That's it.
Well, thank you, Elliot. Let's change the share.
And with that, I'm going to excuse myself. Have a very good afternoon.
Yeah, 1 a.m. I feel you.
Hello. Hello, everyone.
Yeah, we can hear you, but your volume is pretty low. If you can either move your mic more closer to your mouth or increase your mic volume.
Oh, okay. This.
Yeah, this is way better. Thank you. Yeah, wonderful. Thank you.
Okay. Hello, everyone. I will introduce Brusky CLE, a certificate-less enrollment protocol in Brusky. Next page, please. Yeah, IoT devices have been widely used in various scenarios, such as smart cities and smart healthcare. Take smart medical care in the hospital as an example. In this scenario, an IoT device accesses the hospital's network through the gateway. An authentication center is responsible for issuing credentials to the IoT device and the gateway. Thus, they can use the credential to authenticate each other. In this scenario, the gateway cares about whether the IoT device is legitimate rather than who is the IoT device. Therefore, if X.509 certificates are used in the authentication, the identity information in the certificates is redundant. The authentication mechanism for IoT devices should be lightweight and scalable, as IoT devices are commonly resource constrained and have a huge number. Next page, please. There are mainly three existing authentication mechanisms based on asymmetric cryptography, X.509 certificate, raw public key, and identity-based cryptography. A certificate is commonly contained in a certificate chain. A certificate chain has three certificates at least. And entity certificate, CA certificate, and root certificate. A non-certificate chain needs to massive volumes of transmitted data and a non-verification time. C509 certificate has a smaller size of a certificate, but still relies on the certificate chain. Thus, certificate-based authentication is not lightweight. The raw public key lacks scalability because the peer's public key must be obtained via an out-of-band method previously. In IBC, the device's private key is generated by an authenticator center. This method is not secure. However, IBC is lightweight and scalable. The identity is also the public key in IBC, and there is no need to make out-of-band configurations. Next page, please. Certificate-less cryptography was proposed to deal with the key escrow limitation in IBC. The user obtains the full private key by combining the partial private key with a secret value. The partial private key is generated by a trusted third party inherited from IBC. Certificate-less cryptography is also lightweight and scalable. The user's public key derives from the user's identity in this draft. Next page, please. Bruce key is an excellent automated bootstrap protocol. There are 5 phases in the bootstrapping process of the pledge. This draft focuses on the enrollment phase and the phase after enrollment. All existing enrollment protocols use a CA to issue local certificates to the pledges. After enrollment, the pledge uses the local certificate to authenticate each other. Next page, please. Bruce key CLE is a lightweight enrollment protocol for constrained IoT devices. A public key-based credential replaces the certificate AC replaces the CA to issue the credentials. A mutual authentication protocol is proposed to show the usage of the credential in the authentication after enrollment. Next page, please. Compared with certificate authentication, certificate-less authentication improves more than 50% of computational capability and about 80% of transmission capability. Next page, please. The only change in architecture is that the CA is replaced by the AC. It is assumed that the AC and the registrar can authenticate each other. The next page, please. In the initial phase of the enrollment protocol, the registrar sets the devil ID of the pledge on the analyst in the AC. Then the pledge requests the public key and the credential from the AC in sequence. The next page, please. In the mutual authentication protocol, the client and the server make the credential exchange and the proof of position exchange in sequence. The next page, please. That's all. Thank you. Any question?
Yeah, there are two hands up already. Hannes is first.
Yeah, the first one was about the first slide, which was sort of the problem statement saying this one. The gateway cares about whether the IoT device is legitimate rather than who the device is. And I was wondering how the solution that was presented later ensures that there's this legitimate check somehow done. I don't understand, like, how do you determine that?
Yeah, that's a good question. The IoT devices will be authenticated by the Brewski by using the virtual and the initial certificate in the IoT devices. After the authenticated by the Brewski successfully, we will step into the enrollment protocol, and the legitimate is based on the previous authentication in the Brewski.
Okay, so it's actually, you actually don't, it sounded like here you are trying to replace a solution that is based on who the device is with something that is based on the legitimacy, but in fact you are actually not changing that at all. You keep what was there in Brewski to begin with, but what you do is you change, if I'm correct, you want to change the entire Brewski protocol, because Brewski is based on DLS, but in your comparison, you don't, or in the slides, it didn't seem like you're using DLS again. Are you still using DLS?
Yeah, we just changed the enrollment protocol. Please, the next page.
Right, but so like you made this comparison where DLS is shown as really bad and then the new solution is much better, but you're still using DLS. So how is that possible then?
We just changed enrollment protocol, and in the former steps of the Bruschi, for example, there is a TLS connection between the pledge and the registrar. We do not change this. After the enrollment, the pledgers use the credential to authenticate each other. Originally, they use the certificate. This what we changed.
So okay, and so in Bruschi enrollment, you use, if I recall it correctly, like a CSR, a BKCS, then CSR, and then you get a response, like the certificate back, the X549 certificate. Is your proposal to use a regular CSR, maybe with extensions for the identity-based crypto? Like, I don't understand what the new functionality is. Where's the new functionality? Do you replace that certificate request and the response to it?
Yeah,
Michael was typing something in the chat. So, Michael, if you want to answer or help answer.
The answer, Hannes, is yes. You do the whole Bruschi flow with the IDEV ID, with TLS and provisional TLS and a MASA and a voucher, after which you get a authenticated EST connection on which they're going to do a different enrollment protocol. I don't know if it's a variation of a CSR exactly, but there's some details in the document that I didn't understand.
Okay.
Why it's not ACE EST or COTS, I asked yesterday, and I don't know the answer.
Okay, that's okay. That really helps. But I think if that's the case, the performance comparison and these sort of comparisons here that are shown on these slides are incorrect, because you are still relying to some extent on X509.
So the comparison is after you're provisioned. Now you want to talk from device to device. And so now you're going across the, doing some protocol, and now you're going to basically use some kind of raw public key with some kind of a authenticity token, which if it sounds like OAuth, it is a bit, I think. Sorry, if it sounds like ACE, it is a lot, but it's not the same. And so then you're doing that. So imagine you're keying whatever, I don't know what protocol, you're keying your security from device to device using something else that's not a certificate and maybe is not TLS, but maybe is. Okay. Maybe TLS with raw public key plus something else. I don't know.
So it's the comparison is against like a very specific configuration of TLS 1.3 with
a certificate.
With a certificate.
With a certificate, yeah. Yeah.
Against some unknown protocol. Okay.
Yeah, I agree. So I would say keep it more high level, and at this point, just understand what he's proposing.
Bob Moskowitz. Over the past 20 years, I've seen IBE/IBC being put forward as a way to fix some problems without ever addressing some of the basic security issues behind IBC. There's some statements you make here on your first slide about the scalability. I've never seen IBC scale reasonably well in a safe way. I'd be very interested in looking at your security considerations, because if you go back to the NIST report on IBC from 20 years ago, this was one of the biggest issues in terms of the risk of this, in terms of the central store is a major security risk in terms of if it's attacked, the whole system falls apart, seriously falls apart. So I'm very interested to see how your security considerations address that and what what alternative you have to that. As far as the lightweight issue with X509 and IoTs, we are addressing this separately. NIST now has a lightweight cipher ASCON, for our AAD, and for our hash. So visiting our digital signing using this new lightweight hash will make a major improvement in what we're have to do in terms of code base, get the SHA totally out there, do everything in ASCON. That will vastly change and open things up in the IoT framework. Maybe not see everything done to the end of the year, but nonetheless, even this will take a while to do. I'm very leery of any IBC. We all will have to look at it very carefully and have to have some very serious review of it, because it has historically been pushed aside for other solutions because of its underlying architectural model. And so I've put forth my particular view. I have not spent a lot of time in the past 10 years looking at it. I've had other things to do. There may have been advancements in it in the last 10 years. I don't know. And that's my view of it. If you want, I will take a look at this document and put my view in. But there are people who have worked on IBC more recently than me and can make a much better security assessment on this proposal and how it fits in. And I definitely wonder its scalability. This may be good on a small scale use environment inside a home or something like that. But if for some large global sensor environment, boy, I'd be scared to death of it.
As I showing in the in this page, I say the IBC is a knockoff of security, and I say the scalable. That is to say there is no need to make a out of band configuration. This is what I mean, the scalability in IBC. And our draft is not based on IBC, it's based on the certificate-less cryptography. In the next page, as in the page 4, I think we are based on the certificate-less cryptography. We are not based on IBC. And the security of our scheme, we will go to the working group CFIG to promote our algorithm in this draft. And we already have some security proof for our protocol.
I guess we'll have to spend some time looking at it. The initial TLS step in IBC is your out of band step. So we say it has no out of band, and you go back to Revest's proposal and other things back when Revest first made the challenge on this. I argue that we always have an out of band step in one form or another, and we're kind of a bit playing with words on that.
Yeah, to pile on to that, what Bob said, I completely agree. I think this slide is a little bit misleading. It sort of like favors or balances the different mechanisms unevenly, because in the IBC case, it's like a Kerberos type of mechanism. And of course, you have to, in order to use the KDC, you have to register something. Otherwise, the KDC would hand out credentials to anyone, which would be a little bit weird compared to the other mechanisms. I think so. I think this has to be framed in a different, more neutral way. I understand that you have a preference for the identity-based crypto here in the solution, but I think even in that case, you need to sort of treat the different techniques fairly. I think it's fine to propose it, as Bob, I have seen it coming, being proposed numerous times, and it has these limitations, and that's why it hasn't found acceptance. That's why you don't find it in hardware for acceleration. So all sorts of problems that you have to overcome.
Yeah.
Okay, any other comments or questions? If that's not the case, then thank you for your presentation. And yeah, please take into account the in-room comments and try to address them. Also, this was our final presentation for today. So Warren runs to the mic and is, of course,
Whoever
the boss.
spoke and asked comments should please look at the minutes that I took, because they're fairly crappy and they're definitely going to need some editing. There are many like inaudible and random bits that I put in there. So if you made a comment or spoke, please make sure that I got some sort of vague thing that looks kind of like what you said.
To operationalize what Warren just said, if you said something, check it in the minutes.
What did actually match to what you said?
Yeah, and if it doesn't match and you'd still like it better, take Warren's version. So that's okay. Okay, thank you, everybody. We can give you back 1/2 hour of your life. And thank you for attending. See you all next 118 in Prague. And yeah, we will, I guess, hunt co-authors, I think. We will use a net, an IoT net, probably.
Where can I subscribe to the feed?
It will be an unsupported Atom feed.
That sounds exactly on brand.
Hello. Yeah. Oh, yes. Nice to meet you. Yeah.
I think you edited some of the minutes. Thank you very much. It was like something.